Can you solve this tricky geometry question that was once asked in the SAT entrance exam? We are given a right-angled triangle with a base of 15 units and height of 10 units. Inside this right triangle, a semicircle is placed like this in such a way that its center lies exactly on the hypotenuse. And our goal is to find the area of that semicircle. You can pause the video and take a moment to think about it, and when you're ready, you can always come back to verify your answer. Alright, let us solve it together. But before we begin, let's first mark the center of this semicircle. It is given that the center of the semicircle lies on the hypotenuse of the right triangle. So let's mark this point right here on the hypotenuse as the center of the semicircle. Now let's draw two radii from this center point to the other two sides of the triangle like this. These two sides of the triangle touch the semicircle externally. That means they act as tangents to the semicircle. And according to the tangent radius theorem, that is whenever a radius is drawn from the center to a point where the circle touches a tangent, it is perpendicular to that tangent. So this angle here is 90 degrees, and this one is also 90 degrees, correct? Now look at this shape formed by the two radii and the two tangents. These two angles are 90 degree, and we have given that this angle as 90 degree. So this fourth angle must be equal to 90 degree, right? Now since all four angles of this figure are right angles, that means this figure is a square. Since it's a square, all the sides are equal. So this length must be r, and this length over here is also r. Now let's focus on the base of the triangle. The total length of this base is given as 15 units. So if this length is equal to r, then this remaining part must be 15 minus r units. Similarly, the total length of the height is given as 10 units, and if this length here is r, then this remaining part must be 10 minus r units, correct? Now take a look at this triangle. This triangle has a base of 15 minus r and a height of r, so the area of this triangle will be r multiplied by the quantity 15 minus r divided by 2. Similarly, this other triangle has a base of 10 minus r and a height of r, so the area of that triangle will be r multiplied by the quantity 10 minus r divided by 2. And the area of this square will be r times r. Let's multiply and divide this r squared by 2 and rewrite like this. Did you notice something? This right-angled triangle is divided into three parts. This triangle at the top, this square in the middle, and this another triangle at the bottom. So the area of this entire right-angled triangle is simply the sum of these three parts, right? We are given that base of this right-angled triangle as 15 units and the height as 10 units. So the area of the triangle is 15 multiplied by 10 divided by 2. Now equating area of these three parts to the area of this right-angled triangle, we have r multiplied by the quantity 15 minus r divided by 2 plus r multiplied by the quantity 10 minus r divided by 2 plus r multiplied by 2r divided by 2 is equal to 15 multiplied by 10 divided by 2. Taking r common from this side and canceling 2 from the denominator, we get r times the quantity 15 minus r plus 10 minus r plus 2r equals 150. Canceling 2r from here, and we are left with just 25. So this becomes 25r is equal to 150. Dividing 25 from both sides, we get r is equal to 150 over 25, which is 6 units. So the radius of this semicircle is 6 units. Area of semicircle is calculated by the formula pi multiplied r squared divided by 2. So substituting the value of r, we get area of this semicircle is equal to 6 square multiplied by pi and divide by 2, which is 36 pi divided by 2, or 18 pi square units. And that's our final answer. Pretty amazing, isn't it? What looked complex in the beginning turned out to be surprisingly simple in the end. But wait, before you go, I have one more bonus challenge just for you. Can you find the area of this semicircle in terms of the x and y instead of numbers? Think it through and drop your answer in the comments below. Let's see who can figure it out. If you enjoyed this explanation and learned something new, don't forget to hit that like button, share this with your friends, and make sure to subscribe for more brain-teasing math puzzles. Thanks for watching, and I will see you in the next video.